Hello everyone and welcome to Wider 360. Today we have a question that goes like a conical tank. A conical tank is 10 feet across the top and 12 feet deep. If water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. We want to go ahead and see how we will solve this question. First, I want us to make a sketch of the tank and see how it will look like. The question says it has the vertex down, so I'm going to make a rough sketch of that tank here, and it's in the form of a cone. Okay, I'll bring this one here down and this also to meet that. So let's assume this is the cone with the vertex down. From the question we know it is 10 feet across the top, which means from this side here to that side should be 10 feet. What is also telling us is that the radius will be 5, so we can say half of it is 5. This will be the height all the way down here. That will be the height, and from the question we also know that the height was given to be 12 feet, so I'll label this side as 12, which will be the height. That's 12 feet. We know there is water that is flowing into the tank at a rate of 10 cubic feet per minute, so that one tells us it's a rate, so it will be the rate at which water is flowing into the tank, which is the V, with respect to time, the rate at which the volume is changing with respect to time, and that one is 10 cubic feet. So F cube per minute, so per minute, that's that rate. And we have to find the rate of change of the depth of the water when the water is 8 feet down. So let us make an assumption here. We are going to say there is a height. You are going to assume there is a height here. We will call that height h. So I'm going to assume there is a height here, which is h, and that height is going to be the depth of the water. And at that point where we have the h, we can, let me just go ahead and make something like this here so that we can get another radius here, r. We will assume r to be that radius. That's the radius of the water. Looking at this rough sketch over here, we can see we have some two triangles here, one with a radius of 5 and the other with a radius of r. I'm going to make a rough sketch of that over here. We have 5 here, we have small r here, we have here to be h, and the whole of this side to be 12. That's what I mean. So from similar triangles, those two are similar. From similar triangles, I'm going to erase these. From similar triangles, we know that r divided by 5 should be equal to h divided by 12. And then here we can make r the subject. Making r the subject gives us r is equal to 5h divided by 12. 5h divided by 12. And we know the v dt was 10 from the question. And we want to find the h dt as the rate at which the depth of the water is changing when the volume is 8. We know the volume of a cone to be equal to volume of cone is equal to 1/3 pi r squared h. 1/3 pi r squared h. So from here, we know r, which was 5h out of 12. So let's go ahead and find the volume. At this point, we can say the volume of the cone is equal to 1 out of 3 pi r with 5h out of 12. We are going to square r multiplied by h. And then squaring this one, okay, let's say the volume is going to be equal to 1/3 pi, okay, let's assume that's pi. This will be 25h squared, right? Yes, 25h squared divided by 144, that's 12 squared. All of this times h. So we are going to get something like the volume is equal to 25 pi h cubed divided by 3 times 144. I'll close that here. That becomes the volume. Now let's differentiate this volume with respect to t, with respect to time. So the v dt will equal to, we're going to get 25 pi out of 3 times 1, and then over here we are going to get 3, we are differentiating this, we are going to get 3h squared divided by we are going to get 3, we are going to get 3h squared d h dt. It's more like implicit functions. 3h squared dh dt. And at this point we can make the h dt the subject. Let me simplify this first. We're going to get 25 pi out of 144. Yeah, the 3, this 3 can take care of that 3. A, the h, the t, and this is the v, the t. Let's make the h dt the subject here. The h dt be equal to 25 pi (44). Okay, out of that, and then at the denominator side we will have h squared down there, and then at the numerator side we are going to get dv dt. I believe that's correct. Yeah, it's like this, multiplying that and then dividing by this. Yeah. At this point we will go ahead and do some substitutions. From the question, we know it said we had to find the rate of change of the depth of the water when the water is 8 feet deep. So h is equal to 8. We know h to be 8 feet, and then we know dv dt to be equal to 10 cubic feet per minute. Yeah. So we will go ahead and do those substitutions to get the h dt. So the h dt will equal to 144 divided by 25 pi times squared times 8 squared, all of that divided times divinity, which is 10. So simplifying this, we will get let me use a calculator here. 144 divided by 25 divided by 8 times 10. Okay. Okay, let me go like that. Let me go like this. Let me go like this. So we will get the h dt to be 1440 divided by 8 squared will be 64 times 25 will be 1600. So this will be 1600, right? 1600. 1440 divided by 1600, that goes to 0.9. So 0.9 is the same as 9 out 9 out of 10 pi, and that's the h dt, so rate at which the depth is changing with respect to time. So it's going to be cubic feet cubic feet will be volume, so it's going to be just the depth, which is feet per minute. Feet per minute. Let me just write per feet per minute. And that comes the answer to the. Thank you very much for watching the video. Please, if this is your first time, kindly subscribe to the channel and don't forget to like the video. Thank you very much. I will see you next time.